Hello everyone, welcome back to my channel Study with Self. I am Safia Khalid and you are watching the MSRIT IoT Lab series using the Raspberry Pi. Today is experiment number 2, wherein we'll be looking at the switching of an LED based on LDR reading. So let's get started. The flow of today's video is as follows. We shall begin with taking a look at the resources required, followed by the circuit diagram, and then have a look at the Python code, which will then be followed by the demonstration of the working video, and finally we'll conclude the summary. Beginning with the resources required, first and foremost we need the Raspberry Pi 4B microprocessor, and we require our LDR sensor. We're just going to be using one sensor, and to notify or to notice the changes produced by the sensed input values, we will be using an output device, in this case an LED. Whenever we use an LED, we need a current limiting resistor accordingly. In this case, we are just using a single LED and a single resistor. And finally, to make all the connections, we require jumper wires, and it is recommended to use a breadboard to ease the connections. Now, LDR, it stands for light dependent resistor. Let's now have a look at the circuit diagram. When you look at the LDR sensor, it is basically a 3-terminal device, and the various terminals are as follows. We have the VCC, which is connected to the 5-volt power supply of the Raspberry Pi. We have the ground pin, which is connected to the ground terminal on the Raspberry Pi. And finally, we have the third terminal, which is the D0 terminal, connected to the digital output. Digital output in this case is any of the GPIO pin of your choice. So accordingly, we've chosen GPIO pin 2 for making the connection to D0. VCC has been connected to 5-volt, and ground has been connected to the ground pin respectively. As seen earlier, the LED connections are done in such a way that one end of the resistor is connected to the GPIO pin, the other end of the resistor to the anode of the LED, and further, the cathode of the LED is connected to the ground terminal. Apart from these connections, we will be connecting the monitor screen using the micro HDMI port on the Raspberry Pi, and the power supply is given using the C port on the Raspberry Pi, and the keyboard and mouse are connected using the USB ports. The resistor used in this case is 330 ohm resistor, and this is the actual component symbol of the LED, and this is the electrical symbol of the LED. Now talking about the principle of the working of LDR, or the light dependent resistor, it works on the principle of photoconductivity. Photoconductivity essentially means that the resistance value changes based on the values of the light intensity. To depict this relation, this particular proportionality formula has been written. The resistance is directly proportional to 1 by light intensity, or in other words, the resistance is inversely proportional to the light intensity. As the light intensity drops, the resistance of the LDR increases. So whenever this happens, it indicates that the state of LDR is in a way true. And when the GPIO pin becomes true, we are going to be writing a logic such that we'll be turning on the LEDs anytime it is dark, and this darkness is detected by the low light intensity values detected by the LDR sensor. Now, whatever was explained before can be written in the form of the Python code. To begin with, we require our libraries. We need rpi.gpio library and the time library. We're importing rpi.gpio as the alias name GPIO. We're doing a few other non-mandatory statements, such as setting the warnings of the GPIO pins false using gpi.setWarnings false. This will not produce any kind of unnecessary error messages, not error, but then warning messages regarding the channels currently being in use on the terminal screen. And gpi.cleanup is initiated every time you run the program so that the previous state of all the pins is erased and we are newly loading the code. Then again, we are setting the mode of the GPIO pins with GPIO.BCM. BCM stands for the Broadcom mode. We are using two GPIO pins. The pin which is used with the LDR sensor is named as LDR_pin, and we are using pin number 2. Similarly, the pin which is connected to the LED is named as light_pin, and we are using GPIO 4 for that purpose. Once you define the variables, we need to set the variables as an input or an output direction for the particular GPIO pin. So that is done using the GPIO.setup statements. The LDR pin is set as GPIO.in because it is connected to the sensor, which is an input device. Similarly, the GPIO.setup for the LED pin, light pin, is set to GPIO.out because the LED is an output device. After the basic definitions, we have our forever loop, which is being initialized. Within the forever loop, we have the condition, that is whenever the input value detected by the LDR pin is true, that is whenever the intensity of the light is very low and it is dark outside, the LDR pin's GPIO is in turn true. And when that happens, we will be igniting the LED pin using GPIO.output and setting the light pin to true. If the intensity of the light surrounding the LDR sensor is very high, in that case, the light pin is set to false, that is, the LED is turned off. Hence, based on the intensity of the light, we are turning on and off the LED. The code is also available in the description box below, and you can use it. Now let's take a look at the demonstration of the video. So as per the circuit diagram, connections have been made. Only the VCC of the LDR sensor hasn't been connected yet. Once you connect it to the 5-volt supply of the Raspberry Pi, you see that the two green lights of the LDR sensor turn on. This is because it indicates that it's properly powered. The ground terminal and the VCC terminals have been connected correctly with that of the Raspberry Pi. The other connections are nothing but the GPIO pin. It is connected to pin 4 of the Raspberry Pi, and then we have the ground terminal which is connected. With respect to the LED, we have one end of the resistor which is connected to the LED anode, and the cathode of the resistor is in turn connected to the ground pin of the Raspberry Pi. And the other end of the resistor, the red wire, it is connected to GPIO pin number 4. So these are the basic connections. And if we go back and look at the code which has been loaded onto the Genie software, I am quickly compiling it, and it says compilation finished successfully. And once I run the code, you can see that to depict that the intensity of the light is low, I'm just hovering a bit near the LDR sensor. When the intensity of light is low, the LED turns on, and when the intensity of light is high, the LED turns off. Hence, this is the working demonstration of the entire experiment. To quickly summarize the learnings of this particular experiment, on the left is the circuit diagram required for the experiment, and based on the working video seen, this is the truth table that can be formulated. Whenever the level of the light intensity is low, we say that the LDR is turned on. That is nothing but the state of the GPIO pin 2 is true. In that case, the GPIO pin 4 also gets activated, and since an LED is connected to the GPIO pin 4, the LED turns on as the output. And whenever the light level is high, the LDR is set to be off, and since it's in a false state, we do not enter the if loop, and the GPIO pin 4 is also false. In turn, the LED is turned off. So this concludes experiment number 2. Thank you for watching. If you enjoyed the video, subscribe to my channel, like and share the video with relevant people around you, and you can navigate to other videos on my channel by clicking on the videos over here. Thank you.